All right, I think we're filming here. We are going to do some sample problems from one variable inequalities. All right, so here's just a simple word problem, and it's just saying a number, some mystery number, let's call it x, is more than -3 but less than 2. So you can do this just by sort of thinking it through, that if x is greater than -3, you've got to go -1, -2, -3, and just circle that, because greater than is not equal to, it is only greater than, and greater than is going in this direction, but less than 2. So this is 2, and again, it doesn't say we can be equal to 2, it just says we have to be less than 2. So we use the open circle to represent a boundary that we cannot occupy. All right, so you can't be there. If I could be there, I would shade it in. So if it said less than or equal to 2, I'd be good. But that's all you need to do right there. We're not writing an equation. All right. So now here, do the reverse. All right. If we've got this drawing representing some quantity that can be equal to, that's -1 right there, and less than that, or it could be greater than 1, 2, 3, 4, 5, so that's greater than 3, and not occupying 3, we're just going to simply say two different little equations, that x must be either less than or equal to -1, or we can just use the word or, x can be simply greater than 3. All right, so you can just write it in two separate equations. If we wanted to, we could have written this one up here mathematically as x is trapped between 2, it's got to be less than 2, but it has to be greater than -3. We could write it like that. Okay. Then this next one, it says the absolute value of a number, that's number, is less than or equal to 6. Okay, so the absolute value of some mystery number x is less than or equal to 6. All right. Well, to graph this, all we need to do is just, again, sort of think through what values, when I take the absolute value of it, will be less than or equal to 6. Well, that's just going to be between 6, there's 5, and I'm going to circle 6 right there. And there's -5 and -6. I'm going to circle -6 right there. And I'm going to shade in between, because any value that's in between those, when I take the absolute value, will be less than, or equal to. There, I underlined it and I didn't even follow my own advice. I got to shade that in. All right, so always check your work, so if you make a mistake like I did, you will catch it. All right, and then finally, we're given an equation here. 1 minus 3x is less than or equal to 10. Now you just treat that as if it's an equal sign at the beginning. And to simplify and get down to some final statement, x, I'm going to take away 1 from both sides. And when I do that, I will get -3x is less than or equal to 9. Okay? And now I'm going to divide by -3. And when I divide by -3, I have to remember there's a rule that says that this will now become x, and that will be 9 divided by -3 is -3, but this has to switch, so now it's facing the other way. And that's what I'm going to graph. X is greater than or equal to -3. So I go to -3 if that's 0, and there's 5 and -5, and I'm going to shade going this way. All right, that is greater than or equal to -3. All right. Now, if you want to think about why is that rule that we switch it, if I were to rewrite this as 1 minus 3x is less than or equal to 10, why does that work? Well, I could also just add 3x to both sides. That's standard math, to add 3x to both sides, if you want to do that. And if I do that, then I get 1, and I get is less than or equal to 3x plus 10. And if I then subtract 10 from both sides, I'll get -9 is less than or equal to 3x. And then if I divide both sides by 3, you'll see that I will get the exact same thing I had before. I'll have -3, and then I'll have the greater than end of it pointing towards a positive x. It's just written in a different order with x on this side, but you'll notice the greater than sign right here. And here the greater than end of it is pointing towards the x, so these are the exact same things. All right, well done.